All right, this is notes 10-2. We're going to review a little bit. You might want to stop your video first and see if you can try these two and then check your answers. So for this one, number 1, a equals -1, h equals 2. It's the opposite of what's there. K equals 0. So we know that this has to have a starting point of 2, 0. So D is not one of them. C is not one of them. But these other two have a D of 2, 0. So the A value of -1 means that this goes down from left to right. So A is the answer. The domain and range on this next one, we know A equals 2. So we know it goes up from left to right. H equals -4. K equals -3. So we know this is all the x's for the domain, such that all the x's are greater than or equal to -4, because this is where that would be, and it's all the domain, all the x's are bigger than that. The range is all the y values such that the y's are less than or equal to -3. The objective for today is to learn to simplify radical expressions using the product of property of the square roots. For square roots, this here is, alright, so those perfect squares will help us out because like the square root of 1 is just 1. The square root of 4 is just 2. The square root of 9 is 3, etc. Okay, these are called our perfect squares. The next thing you have to know is, in short form, a radical expression has a square root sign. What's underneath this is a radicand. So if you hear that word, that's what it is. A radicand is in its simplest form if the following conditions are true. The only perfect square factor underneath it is 1. No radicands contain fractions, and you can't have a square root with on the bottom of a fraction. So something like this is not simplified. Okay, it has to have the square root of 3 or whatever on the top. We'll learn how to do that later. So here's the deal with multiplying with square roots. If I have a square root, say I have the square root of 16, I'll say 12. The square root of 12, I can rewrite it to be 4 times 3. I can also rewrite it so that each of those have their own houses. And you also can reverse because this is multiplication. So what you're seeing up here are some examples. Square root of 4 times 9 is the same thing as the square root of 36. You're multiplying whatever is underneath the radical sign, but only if it's underneath the radical sign. Anything outside of the radical sign can't be multiplied by the stuff inside unless you do certain things to it. Also, if I need to simplify further, the square root of 4 times 9, I can put each of them in their own house, then take the square root of 4 and multiply times the square root of 3. And that's how they got 6. So we're going to simplify the square root of 52. So if you look at this perfect square list, 1, 4, 9, 16, and 25. Usually that's about as high as you need to go. You can find the perfect square factor of 52. And the perfect square factor of 52 is going to be 4. So I can rewrite this as the square root of 4 times 13. Well, the square root of 4 and the square root of 13 can get their own house. The square root of 4 is 2. Square root of 13 doesn't have a perfect square factor, so this is 2 times the square root of 13. Notice I said 2 times the square root of 13, but there's not a dot right there. You can put a dot there or not, but when it's multiplied up here, it's still multiplied below. So if we do the same process with the square root of 45, think what's the perfect square factor? Square root of 9 times 5. So that equals the square root of 9 times the square root of 5. Square root of 9 is 3. Square root of 5 is as simple as it can be. because there's not a perfect square factor in there. All right, on C, you have an option on how to do this. There's two ways to go about it. One way is to go ahead and just multiply the 2 times the 24. Since they both have a radical sign over them, you can do this. So you get the square root of 48. Then you find the perfect square factor of 48. That would be 16 times 3. Square root of 16 is 4. Square root of 3 is just the square root of 3. There's no perfect square factors in there. Sometimes it happens when we do this that we don't pull out quite enough of a perfect square factor. Like let's say we're doing this one, we have the square root of 48 again. And let's say you recognize that, oh, 4 is a perfect square factor of that. 4 times 12. So the square root of 4 is 2. The square root of 12 you leave in the house. But when you do this, the very last check you should always do is to check the square root, check the radicand and what's left over. Make sure there's not a perfect square factor. If there is, remember this is 2 times the square root. Just go and pull out the perfect square factor and do your process again, remembering that that 2 is out front there. So this is 2 times the square root of 4 times the square root of 3, which is 2 times 2 times the square root of 3. The 2, there was already a 2 out here. You pulled out a 2 from the square root of 4, so you have to put those back together. So this is 4 square roots of 3. So if you don't get the perfect square factor out the first time, then you still can recover, kind of, and just always check that your radicand is simplified. If it's not, keep pulling out factors. Okay, on D, I'm going to do this one slightly different. In fact, you could probably pause the video right now and stop and see if you can do it. If not, here's the answer. So one way to do this is to multiply 5 times 35. And when you do that, you get 175. Then you look at the perfect square list. Say, okay, are any of those factors? You might have to go bigger even, but we'll try 25. So 175 divided by 25 is 7. So this is 25 times 7. So the square root of 25 times the square root of 7. Square root of 25 is 5. Square root of 7 is just 7. Another way to do this is to break it up like this. I took the square root of 35 and turned it into that. Square root of 25 times the square root of 5 is the square root of 25, which is 5. Square root of 7 is as simplified as that can be. So this is 5 square roots of 7. So either way works on this. And that brings up an important point. What is the square root of 5 times the square root of 5? It's the square root of 25, right? So that equals 5. What's the square root of 9 times the square root of 9? Oh, that's the square root of 81, which equals 9. Do you see a pattern? What's the square root of x times the square root of x? This is the square root of x squared, which equals x. So that brings us to these letters. If I have anything that has an exponent that's even, this works great for our perfect squares. Because if I'm doing the square root of a squared, remember the square root is if I can take something times itself and multiply it underneath the radical sign, and then I pull out 1, and that's the solution. So the square root of a to the 4th is the square root of a squared times a squared, which equals a squared. The square root of a to the 6th is going to be a to the 3rd. So the square root of any of these with exponents, as long as it's a even exponent, is just going to take the exponent and divide by 2. So let's look at this one. I've got the square root of 45. We can do that one, times the square root of a to the 4th, times the square root of b to the 5th, times the square root of c to the 6th. Square root of 45 is the square root of 9 times 5. Square root of 9 is 3, leaves behind a square root of 5. The square root of a to the 4th, take the exponent and divide it by 2. So this is a squared. Square root of c to the 6th is c to the 3rd. Take the exponent and divide it by 2. But this b to the 5th is not even. So I could write this as b to the 4th times b to the 1 power. We don't usually write it, but I will. Square root of b to the 4th is just b squared. The square root of b has to stay in the house. So this is a little out of sequence of how I would have you do it, but we'll do it this way. Okay, so I take all the ones that are not in the square root sign. 3a squared, b squared, c cubed, and left behind is 5b. That would be the simplified version of this radical. It's really not as bad as it seems. We'll do this one. You guys try this one, and then we'll see what you get. Okay, so the square root of 32. The square root of 32 is 16 times 2. So a good strategy for this is to take all your exponents and find all the even ones, write your perfect square factors out there. Square root of 16 is 4. Square root of 2 has to stay. Square root of m squared, remember those are multiplied, is m. Square root of n squared is n. Square root of c is just stuck there. Take all your things out of the radical. And then make just one radical. So 4mn square root of 2c. And you'll develop different ways that you like to work with these. The ones that I'm most concerned about with you not getting are the ones where you have like b to the 3rd, c to the 5th. Let's just say 16. So here's one more example. The square root of 16 is just 4. The square root of b to the 3rd, right, is b squared times b to the 1 power. Square root of c to the 5th would be c to the 4th times c. So square root of b squared is b, but the square root of b is stuck there. And then square root of c to the 4th is c squared, but the square root of c is stuck there. So this is 4bc squared square root of b c. And then one more way to look at this, you can expand these out completely. We'll do a different version here. 4 times 4 times b, 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 c, 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 c. So groups of 2 is what you're looking for, and they come out. So this is a 4. Here's a group of 2. They come out as 1 because you're doing the square root. And then here's a group of 2. It comes out in another group of 2. 1c comes out, and then the square root of c. So this is 4bc squared square root of c. So that's just another version of how to do this. Just look at it this way. If I have b cubed, you've got 2 buddies that are looking to go to the movie together. They go out and go to the movie, to one movie. The other one, the one that's left over, pretends like they're sad but realizes that they can watch whatever they want to on Netflix, so they get their popcorn and stay in the house and watch Netflix. All right. You guys have a great day.